Hi Connects, happy to meet you all after a very long time through this video. The intention of this video is to ensure how we can perform a debugging process on top of the streams pipeline. So right now I'm using IntelliJ IDE, which is a community edition. This IDE gives us a better way to debug the stream-based codes. So the snippet of code that I have here is for an order processor system, which is a small piece of code, nothing much complex here. I have captured a list of order objects in a list up here, and the order details are like order ID, the person who placed the order for the amount which he placed for that order, and the status of the order, which is paid, pending, and cancelled are the three version of order status that I'm maintaining here. And I'm trying to create a stream out of it. As you can see, the list of order is orders. So orders.stream is the way where we are initiating the stream. And from here, after the stream is initiated, I'm trying to peek in. So peek method is traditionally used to debug the stream code. From the olden days, we used to follow that peek method to peek into every individual stream operations and try to get to know the outcome of each and every operation that gets executed out of it. So once the order stream gets executed, I'm trying to peek in and get the order ID details. And then once the filter operation is completed, where the filter is, I'm trying to filter only the paid status of the order. So out of 4 order objects that we have in, I'm trying to filter only the order which has a status of paid. So once the filter is done, again I'm peeking in to get to know what the ID of the object is on top of the paid statuses. Then I have a map method. The map method is another intermediate operation that we have, and this map method is trying to transform the order object to an order summary object. The intention of transforming to an order summary is to apply a discount for every order that comes in, and the order summary will get the discounted amount, and the collection of order summary is further captured into a list by using a toList method. Before that, we do have a peek again that is after the map method. So what exactly happens for the summary is captured here. So wherever you can see the peek is all for the purpose of debugging, but that's a traditional way. But what I'm trying to explain here is the way how we can perform through the tool of an IntelliJ IDE. So what we are going to do is, I already placed a debugging point here at line number 19, and I'm trying to initiate the debugging execution. So once we click on the debugging icon, and here you can notice that the debugging window pops up, and here on the more option, you can just click and look out for a trace current stream chain. This is actually a plugin which we need to add into the IntelliJ IDE. Most of you might be aware of it. So if it is something not new, then probably you can skip this video. But this is for the people who really wanted to know how to debug the stream flow. So you can click on this trace current stream chain. What exactly happens is a window pops up. So you can see it's a stream tracing window, and what you can notice in the stream tracing window is exactly the operations that we have listed on the stream. So the first thing is orders.stream. So in orders.stream, when it's getting executed, how many objects are coming out of the order.stream is nothing but the 4 objects, because the total number of objects that's there in orders list is 4 up there. So all the 4 are listed. So if you drill down further, you can notice each and every order details. That's none other than the order ID, the person who ordered it, and the amount and the status of the order, whether it's paid or pending. It's exactly the same what we can see on the code is what you're seeing on the visual window of the stream tracer. Now, the next thing is we have a peek method. So when I click on peek, obviously we'll end up with 4 objects, because the peek is only peeking once the stream gets executed. So obviously we will get all the 4 objects listed from the peek method, and there is no manipulation happens on each and every object. So it's going to be the same data that's going to be seen inside each and every object that's been listed up within the peek. The next operation that we have here is filter. So if you move on to the filter, what exactly happens is, there are 4 objects being applied on top of the filter. But once the filter gets executed, what is the final outcome is what the stream tracer window is trying to explain. So, or visualize it. visualize for us. So we have two objects. Why the two objects getting listed out of 4 is because we have applied a filter to capture only the order status which is of paid. So if you notice, there are orders which are placed by Alice and Charlie whose orders are already paid, and those two objects are alone getting captured once the filter operation gets executed. After the filter, we have a peak. So what exactly happens on the peak is again capturing the two objects data, and it's getting printed. That's it. We are trying to log them, right? So I'm using the log.debug here to just to get to know the ID of the each and every object which is filtered by the filter method. So it just gives the order status here. Then we have a map method, which is another intermediate operation. And when we jump into the map, what exactly happens is, again, it's bringing up two objects, but the two objects are transformed object post the discount is done. So we have an object called order, which is mapped to this. And if you see, it's order 101, which is carrying a price of 250. If you expand this and see, it's still the amount of 250 in the order summary. Means the order object is now transformed to order summary. That's the essential point here, which we can capture from this tracer window. And we also have another object which is mapped to this, where the order amount is 560, but if you notice, the order amount comes to 504 for this object. So means for this object alone, the discount is applied, but not for the other one. So there seems to be a bug here, because the intention of this order processor system is to apply the discount for the entire objects in the list. But unfortunately, what I've done here is I've applied an if condition. Of course, it's an intentional bug. It's meaningless actually, because we explicitly wrote that method. But this is just to explain the way how we can debug it. So what exactly happens is 103 is the only order which gets its discount, not the entire object. So what happens here is the 103 object is where getting the discount, which is 504. The initial price is 560, but now after the discount it becomes 504. But if you look at the other object which carries the amount of 250, is not getting the discount. So we are getting to know why this object is not eligible for the discount. So now we can go and tweak around on the code and understand, okay, this is the reason that this object is not eligible for the discount. So anyways, this is just a small explicit intentional bug that's been enforced to visualize on the stream tracer window. Now, if you go ahead, then we do have a peak method again, and that peak method is going to talk about the two objects, which is now being transformed into order summary. Before it was order object, but now it becomes an order summary after the map execution happens. So if you expand these two objects, again, you will be visualizing the two object status, which is the discounted version. And now it's not an order object anymore. It's just an order summary object, which is a transformed object. The next method that we have, which is a terminal operator, which we call it as a terminal operations. So in the to list is a method which is going to finally bring up the outcome in terms of a list of order summary. So it's a list, as you can see, and the size of the list is 2. Obviously, we have only 2 objects after the filtering is done and the map is done. But the 2 objects are order summary objects, and the order summary objects are carrying the name, amount, which is a discounted amount, and the order ID in it. So what exactly happens here is we can visualize the step-by-step process of all these operations which are lined up within the stream pipeline. But one interesting thing is we also have a flat mode. When I click on flat mode, what exactly happens is you can visualize all the operations in a one single go. Okay, where we start with the streams, and then we go for the peak, and then we go for the filter, and then again a peak, and then go for a map, and then go for a peak, and finally end with the terminal operation, which is called as a to list. So we are not trying to do it in a traditional way by using a peak method to debug it right now, but I'm trying to explain you how the stream tracer window on the debugging mode of the IntelliJ IDE can help us to quickly visualize the stream operations outcome. So if I just go to the split mode, then we will be able to visualize each and every operation in an independent tabbed mode, and you can able to dig deep into it and see how each and every objects are getting manipulated. So this seems to be a quite interesting stuff, and this has been used in the IntelliJ IDE, which I'm talking about right now. You can also try out. It's a community version. You can just download it and go ahead and look out for a plugin called Trace Current Stream Chain. So you'll be having an option to add that. So if I go to my IntelliJ's settings, where you will be able to see that I have an installed plugins, and on top of this, let's go ahead and say if I have a stream debugger. Yes, so this is the plugin which I'm using right now, Java Stream Debugger. Okay, you can just get this Java Stream Debugger into your IntelliJ IDE, and then you can start meddling with this stream tracer window on top of the debugging mode, and you will be able to easily adopt to this way of debugging your streams going forward. So thank you so much, and we will be connecting with another interesting tip of video coming soon.